Hello class, we're back for another lesson. Today's lesson for, I think it's day 13, Algebra 2. We're looking at quadratic inequalities, okay? So yesterday you had a worksheet on linear inequalities, and hopefully that reminded you how to graph a line, okay, and make it the border line. And either if it's less than or equal to, you're going to use more ink, so you're going to make that solid. If it was strictly greater than or strictly less than, then it's going to be a dashed line. And then you were going to check for one side or the other. Now, I'm not sure how you did that in the past, but hopefully today we'll make that make a little more sense of why we're doing that. For a quadratic inequality, what you see here is, here's a quadratic equation. We have x squared minus 6x plus 9, and we're asking when is it greater than 4? So remember, a solution to that would just be something that'll make the sentence true. So let's check x equals 0, x equals 1, x equals 3, x equals 4, x equals 10. If you have 5 rows, you can each check one, okay, and do that. You go hit pause if you want. In other words, I'll tell you what happens. When I put in 0 here, 9 is greater than 4, that's a yes. We put in 1, let's see. 1 minus 6 plus 9, is that greater than 4? That's negative 5 plus 4 is, no, it's not strictly greater. Interesting though, because I think it was exactly 4. Okay, when I put in 3, we get 9 minus 18 plus 9. So the 9 plus 9 is 18. Is that greater than 4? And the answer is no. When I put in 4, we'll have 16 minus 24, or negative 8, plus 9 is 1. Is that greater than 4? And the answer again is no. And when I put in 10, 100 minus 60 is 40, plus 9 is 49. Is that greater than 4? The answer is yes. And so what we could do is we could look for, I could have each of you try to find a solution. And in fact, everybody in class could get their own unique solution, and then some. So in these, we will have many things that will be true. Another way to look at that is to graphically look at this as 1/2, and to graph that, x squared minus 6x plus 9. We'll call that y equals. And then to graph over here, y equals 4 as a separate graph. And then, to make the sentence true, we're saying when is the blue graph higher or more than this maroon graph, y equals 4. So I can look over here and say, we should recognize y equals x squared minus 6x plus 9 after our quadratics, that is a parabola, okay? It's going to open up, it's going to have a y-intercept of 0, 9, so we know a few things about this, and it's going to do something like that, okay? Y equals 4, I just kind of put that horizontal line up there somewhere, and what we're going to search for now is when will this be true, okay? As you can see, there should be a region over here where this is true. So for these x values, that should be true, and then there's a region over here where these x values should be true, and there's a region where it's not true. Notice that many of the ones that we tested were in this region where it's not true. The question becomes, where is that tipping point between where it is true and where it's not true? And to do that, we're going to take advantage of the fact that parabolas, okay, have a domain that is all real numbers. So when I graph it, it's continuous. So every time when I start graphing a parabola, once I start to put my pencil on the paper, it stays on the paper and I have a nice smooth graph that I'm going to have. The same thing with this other side, y equals 4. That's a nice smooth graph. Because of that for both, neither one is coming off the paper or doing weird things or having a point that's not defined. Because of that, I can take a kind of a shortcut, or I can use this idea that the only time that this truth statement is going to change, okay, it's going to have to cross each other. And so what I'm going to do in order to solve this, I'm not actually going to do an inequality, because I don't have rules for what to do with these x's when I don't know what x's are. Eventually I'm going to have to do some division or some multiplying by x's, and I don't know what x is. And if x is negative, that switches the sign. If x is positive, it keeps the same sign. But until I know what x is, I can't do that. So it's not legal to use the same ideas that you did for linear equalities, you know, when we were doing that. So what I have to do is say, you know what? The only time it's going to change, the truth, is when we have it be equal. Now, this is what your books will call a critical point. We'll be searching for critical points. So I'm going to do an inequality, not by actually trying to solve an inequality, but I'm going to make this an equality and find critical points. So this left side, how can I figure out when this equals 4? Hopefully you recognize the left side is a perfect square. we have completed the square there. Interesting, completing the square, using it. X minus 3 squared is 4. We'll take the square root of both sides. X minus 3 will be plus or minus 2. Okay? And then x will equal positive 2 plus 3, or x will equal negative 2 plus 3. This is x equaling 5, that is x equaling 1. What that tells me is that right here where it crossed was at 1, and the second place where it was exactly equal was at 5. Now, if we're not sure, because we don't have a graph here, we wouldn't have to have a full graph. We've just found critical points. Now let's check the regions. Okay? Now, graphically, if we're 100% sure that we graphed this exactly right, you're just looking at the graph saying, okay, before 1, the blue is above the maroon. It's true. Between 1 and 5, it's false. And after 5, it's true. And I have my solutions. But the other way to do that is to show me that you're actually, checking this out. Let's go ahead and, hope you can see the green today. Let's check a number over here like 0. Well, we have done that before. Is 9 greater than 4? And the answer is no. Let's check a number between 1 and 5. So I like to say let's check 3. So that means is 9 minus 18. Wait a second. What did I just say? Is 9 greater than 4? No? Huh. I hope you guys caught that. 9 is greater than 4. Yes. Is 9 minus 18 plus 9 greater than 4? Let's see. Negative 9 plus 9 is 0 greater than 4. The answer is no. And then if I check something after this, check 6, then we can plug that in and say we have 36 minus 36 plus 9. Is that greater than 4? And that means 9 is greater than 4, and the answer again is yes. So, my answers here is not just a number. It's not just two numbers. It's a region of numbers. The answer to this is x's that are less than 1 or x's that are greater than 5. Now, I can't say and, because there's no number that's both less than 1 and greater than 5. It's got to be one or the other. So any number less than 1 will be true, and any number greater than 5 will be true. And it wasn't or equal to, because this was a strictly greater than sign. Okay? So that's just one example of how to do that. Maybe what we should do is have you try another one. And let's see. If we can go x minus, plus 2 squared is less than or equal to 3. Okay? And what we want to try and do is, can we look for these solutions without showing a graph? Let's just look for a solution here. So we're going to say, okay, my critical numbers are when x plus 2 squared equals 3. So x plus 2 is plus or minus the square root of 3. X equals negative 2 plus or minus the square root of 3. So now we're going to have an idea of about what this is. So I don't have a calculator with me. So I know the square root of 3 is about 1 point something. So this is about negative 0.7 or so in that region. And if I take negative 2 plus that. If I take negative 2 minus that, the other one is x equals negative 3.3 something. Okay? So I only have an idea of about where this is on a number line. So, because I don't have a calculator. Now you guys have a calculator, go ahead, figure out the decimal, know where that's at, but I can still do this because if I'm pretty close. When I check things, let's just check things that we know are in that region. Because this is where it'll be critical, be exactly equal to, and I'll check the places where I know it's going to be over here. Like, let's check negative 10. That's definitely to the left of negative 3.3. We check negative 10 plus 2 is negative 8. Negative 8 squared is 64. Is 64 less than or equal to 3? And the answer is no. I need a number between these two that's definitely there. How about negative 2? Whoops. We'll be checking negative 2. Negative 2 plus 2 is 0. 0 squared is 0. Is 0 less than or equal to 3? Yes. And I need something over here. I would usually check 0, but that's kind of close. Let's just check 4. We'll make sure we're way over to the right there. If we check 4, 4 plus 2 is 6. 6 squared is 36. Is 36 less than or equal to 3? And the answer is no. So let's remember where this one came from right here was negative 2 minus the square root of 3. Where this one came from was negative 2 plus the square root of 3. My solutions then are the things that are stuck in between. Okay? And it's a less than or equal to sign. So it's this region right here, meaning from negative 2 minus the square root of 3 is less than or equal to our answers, which is less than or equal to negative 2 plus the square root of 3. And those, that would be the exact location. And you could certainly use the decimals to get an idea for some things, and we may ask you for the decimal. Hopefully, class, that gives you an idea how to do quadratic inequalities. This method we will keep using throughout. So no matter how hard the inequality is I throw at you, if you use this method of finding critical numbers and checking regions, it'll always work. We won't have to learn new things. We can learn one thing and just keep repeating it. So that's the method that we're going to try to do for the day 13 work.